Good morning, everybody. Today I would like to present the Big Climate Database. This is a database of 500 supermarket food items. We are very proud of this work because in the end of 2021, it was awarded the Nordic Council Environmental Prize, an award that was won by Greta Thunberg in 2019. In this presentation, I will first introduce the context of the study, then show how the food database was developed, and I will conclude showing how the database can be used. So let's start with the background. A recent WWF report shows that we lost almost 70% of the global wildlife in the last 50 years. Food production is responsible for 29% of the global greenhouse gas emissions, and the land use changes alone are responsible for 11% of these emissions. Therefore, addressing the impact of food production is pivotal to solve the current climate crisis. The development of the Big Climate Database has been funded by the Selling Foundation, which is part of a Selling Group, the largest retail group in Denmark. The modeling has been performed by 20LCA consultants in collaboration with Concito, which is a Danish think tank, environmental think tank. It includes the detailed data for 500 food items at retail in Denmark. And the database is among the largest and most complete of its kind at the moment. The rationale for its development was the demand for data to guide consumers towards choosing the food that can mitigate climate impacts, and is therefore targeting consumers, but also retailers or food service providers in general. So the methodology that we use, we follow the life cycle assessment standard 14040, 14044 from the International Organization for Standardization. It is therefore a consequential LCA, which avoids allocation by substitution. This means that the model will follows the cause-effect based relationship and also keeps all the mass balances, and also the balance of other properties are preserved. And it also includes the indirect land use changes, greenhouse gas emissions. This also means that we do not follow the European Union PEF guidelines because those treat by products by allocation, which means that the mass balance and the other balances are violated. The allocated activity in reality do not exist, and the effect of byproducts is actually not modeled, but instead hidden behind the allocation factors. Moreover, the average supply mixes are used in the PEF guidelines. So average includes constrained suppliers, which actually are not affected by the change in demand. So for this reason, we do not follow this approach, and we instead follow the consequential LCA approach. Now a bit of information about the calculation methods, how the database works. So the model is built with separate modules accounting for all the activities contributing to the production of the 500 food products modeled in the database, such as the crop production, the animal farming, transport, packaging, food processing, and retailing. And of course, all the emissions for those are included and then expressed as a CO2 equivalent and attached as emission factor to the food item. Modeling food at the Danish market involves the import of crops, animals, and processed food items from all over the world. So in order to model these 500 data sets, we had to, as part of the development of the Big Climate Database, we had to model all crops and animal categories in all countries in the world. This also means that the current version of the database can easily be expanded to cover 500 food items in retail in any other countries in the world. Performing an LCA of 500 items is an exercise that can only cannot rely on the conventional bottom-up LCA, modeling one product at a time. That would have been impossible. So here we modeled everything in one go by triangulating data from a number of statistics, emission factors, and several data sources, automating the calculations with the software modules. The development of the database was inspired by four key principles: consistency, completeness, modularity, and scalability. Consistency means that the same modeling principles and emission models were used across all crops, animals, and food processing industries in all countries in the world. Completeness, because no flows have been cut off in the life cycle inventories, and this was possible by using as a background database the multi-regional hybrid input-output database, XIO-based. Modularity, because any calculation module can be revised or replaced very easily. And scalability means that the number of included crops, animals, and food processing industries, countries, years, etc., can easily be expanded, and the entire model can actually easily be updated with newest data from global databases or updated to a new year when new data are available. Then next, I would like to discuss how we model fish in the Big Climate Database. There was actually a specific focus of this presentation on showing how the fish were modeled. This is because it is a very good example of how we model constrained resources in consequential LCA. In fact, if we think about consumer demanding of fish, the first thing that comes in our mind is that there will be actually an additional landing of fish from the fishery. So wild caught will be the one that provides this. The fish will be wild caught. But in reality, if we look at these FAO statistics, we can see that already in the last 30 years and more, the amount of wild caught fish, it has plateaued. So we cannot fish more than we are already doing. So we cannot land more fish. So in reality, the cause effect will be that as a consequence of a consumer demanding fish, this additional unit of fish cannot come from the fishery. But if we look at the chart below again, we can actually see that instead is aquaculture that is increasing, and therefore is responding to an increase in demand of fish products. So what we did is we use fish statistics to identify what are the marginal countries and the marginal fishes that respond to a change in demand by dividing the fish species from between marine fishes, backwater fishes, and crustaceans and mollusks. For each of them, we identified what is the marginal source and species. Now some information about how the database can be used in practice. Well, first of all, there is a website that can be accessed from anybody, from consumers or whoever is interested, where the impact of the 500 food types can be looked at. But it can also be used, as we had discussed before, by canteens, restaurants, and any service supplier. For example, if they provide or if they have the spend data, then we know the food item that they have bought that is linked to a classification, which correspondence tables can be bridged to the classification that we use. And then if they indicate the amount for each food type, we can link this to the emission per unit of each food type, and therefore we can calculate the actual emission for all the food items that are bought by this canteen or this restaurant. It can also be used by consumers, as I said before. They can just look at this table to understand how they could replace their products in their diets with the products with the lower greenhouse gas emissions. So how consumers can change their consumption in order to reduce the greenhouse gas emission of their diet. And moreover, it can also be used by supermarkets for creating a greenhouse gas emission labels based on life cycle assessment data. So there are therefore multiple uses of this, and we foreseen also to, as discussed, to update this database frequently with new data, and also to optimize it. And with that, I would like to thank you for your attention, and I hope there will be questions. Thank you.